This is the base of the workpiece, base of the engine, and I'm going to drill the mounting holes to go into its mount in the workpiece. And I think they're almost arbitrary where they go. Somewhere close to the edges of the workpiece is fine, but I'm using Toley's excellent drawings for some of this. I downloaded them at Mr. Pete's. Mr. Pete gave the Toley's email address, and he'll, if you use it, which I'll provide later, he will send you a bunch of seven JPEGs, I think, that you can then print off. They're excellent, so I'd recommend you do that. Anyway, Toley says 0.312 from each edge for the holes, and I'll get to how large they are here in a minute because I've forgotten. I like to work from 0, 0 location. I'm just going to arbitrarily call this 0, 0. So this hole will be at 0.312.5 in XY coordinates. Since this is an inch thick, it'd be 0.5. Actually be minus 0.312, wouldn't it? Because it's in the second quadrant. So we're going to find this 0, 0, then we'll position it at minus 3.12 plus 0.5 and drill that hole. Generally, you're not supposed to run a edge finder in a drill chuck. You're supposed to run an edge finder and collet. But as I mentioned earlier, these holes are not critical. So I'm thinking this drill chuck is going to be good enough. There we are. Come in 0.312 to get that dimension. Don't forget, since this is the edge finder's got a half inch diameter end on it. You've got to come in half of that, so it's an additional 1/4 inch. Don't forget that. Find this dimension. Find this edge, I mean. Getting close. There we are. Alrighty. I noticed that I turned the spindle off before I raised it. And that's because if you don't, on this square edge, this edge finder will try to walk up over it, and you'll likely ruin your edge finder. But in my case, since I'm almost at my limit of travel vertically, I couldn't have walked over it anyway because I don't have that much room. So I will stick a center drill in there. Okay, we've got a center drill inserted. I'm using a number 2. Couldn't find a number 1. Number 2 would be fine. So we need to come in half an inch plus a quarter of an inch to take up for the half-inch diameter edge finder I use. So half an inch and a quarter of an inch is, if I calculate this right, it's 3/4 of an inch. By magic, we're at the center of everything. It doesn't hurt to do the stupid test. Little mark on the piece and see, and then a quick measurement proves whether I'm stupid or not, and I wasn't. I'm going to center drill for number 29 drill bit, which is what's required for an 832 tap thread. Didn't take much. I'm running at the highest speed my mill will turn, which is 2950 RPM, and this number 29 drill bit, which is I think I've got to check. Wish I had a chart hanging on the wall. I don't know why I don't do that. It's .136 is at 2950. Calculating here. It's only 105 SFM. So can't spin it too fast in my case. I'm going to do find the zero calculation here, or a measurement. There we go. I'm going to differ from Tubal Cain's engine a bit here. His base of his pedestal on his engine was 3/8 of an inch. I'm going to make mine 1/2 an inch. So we're going to drill a 1/2 inch hole here. Quarter inch. I said it's going to be ½ inch. That's not correct. It's going to be exactly 0.4165. I don't want to go through, I don't want a through hole. I'm going to bring the screws up through the base instead of through the top of this pedestal. If you've seen Tubal Cain's machine, if you've watched his video on this engine, you'll see that his screws go in through the top of the pedestal at the bottom of his engine. Mine are going to come up through the mount and won't be visible at all. Not that it's any better, it's just different. Now on to the next hole. If you remember, I like to center drill, and tap without moving my table. I don't want to center drill all the holes, then drill all the holes, and then tap all the holes, because that requires me to refine the hole precisely each time. Why not just do it all operations on the hole that you can do without moving your setup? If you don't have a DRO, then I don't see anything wrong with the way I'm doing it. It seems like it would save time. Others may think differently. Your mileage may vary. I'll turn this light off in case it's reflecting on the camera. So what I'm going to do is tap this hole. I won't have enough room to finish tapping it because I'm out of vertical space and I can't get a tap handle in there. But I can start it really well, and then it'll be a simple matter to come back and finish it because I can re-thread this tap in there. So of course it's always when you do this and you're out of room, it's always a question of getting that tap back out. And once again, I'll rely on this precision instrument here to loosen the tap up. Okay, pull it out with my hands now, or my fingers. So now I'll reposition the table to create that hole. Alrighty, I need to create a hole 0.312 from this end, but I don't want, I know this is a 2-inch piece. Why go through the process of putting the edge finder in, finding the edge, coming in 0.312 when I know where I am already? I'm 0.312 in from here. So to locate this hole, it's only the location of that hole. I gotta have a pencil in my hand when I talk. The location of this hole is 2 inches minus the 0.312 I already am, minus the 0.312 I want from the edge. So that's do that in my head. It's 1.376. So why not just do that? Why not just turn from where I am 376 or 326? Now I'm messed up. Gotta go back to the calculator too. So I'm just going to turn it 1.376 in the minus X direction. That just means I'm going to move the table that way. Alrighty. So we'll set up to do the stupid test. Long rule. I don't know how people use these rules measured in hundredths. You can just barely see the divisions, or I can just barely see the hundredths. but looks like we're in good shape. Get my finger close to a cutter of any kind until the spindle stopped. Find 0 on the spindle or the quill DRO. What would you call it? The spindle DRO or the quill DRO? I don't know. Doesn't make much difference to me. All right, we're going to go in, what did I say the last one was? 0.416? Oh, it looked like I didn't quite tighten that baby up. So did it really drill 0.416 or not? Well, let's find out. .421, I guess we're good. As I said before, I want a pedestal that's half an inch thick, and I don't want through holes, so I decided to drill them less than 0.5. I chose 0.416 because that's where I stopped the first time, and this one's 0.421, so that's good enough. Now we're going to tap it. Wouldn't it be great if I could slide that tap out under that drill chunk? If I'd gone about 3 more turns, I could have. But I didn't. All right, we're move the table over. And I'm going to tap these 2 holes. Now see how easy it is to start that tap. Makes it a lot easier to hand tap if you already have it started. You don't have to worry about tapping off to one direction or the other. You don't have to worry about, in other words, you don't have to worry about it being straight up and down. So I'm tapping. You've seen tapping before. Whoops, looks like I already hit the bottom. So this is a taper tap. It looks like I've got plenty of thread on it. I won't need a bottoming tap. It turned out I didn't have enough threads, so I'm going to go in with a bottoming tap to pick up a few more. Could use shorter socket head cap screws, I suppose. But it'd be nice if I could get 3/8 of an inch out of this. That is the bottom. So we'll see what we've got. I don't turn my compressor on unless it's for big jobs. That's 3/4 inch 832. And yeah, there's 3/8 of an inch left, so that means it's down in there 3/8 of an inch, so that's good. I'll send that one to the bottom and we'll move on to the next op after that.